Hello guys, today we are going to go into the concept of quadratic equations, and instead of talking about the graphs and how the function looks on a graph, we're going to explicitly work on the concept of finding solutions, also known as zeros when it comes to quadratic equations. And the main techniques that we're going to deal with are solving through just basic equation solving, using the quadratic formula and the factor form. And rather than go into a deep lesson about how to do each thing, I'm going to show you the tips and tricks of how to use them effectively and what we can do with them to make our lives as easily as possible as we work through these kinds of different difficult SAT quadratic problems, and how to take the most advantage so we can spend the least amount of time worrying about it. So first things first, let's go into equation solving. So when you deal with a quadratic equation and you need to solve it, it's very, very similar to, if it's simple enough, it's very, very similar to the way you would solve just a regular equation with just solving for the variable of x. Your job is to get x isolated, and you want to add and subtract before you multiply and divide. So I simply need to divide both sides by 4 first. So now I'm left with x squared is equal to 13. And now at this point, if you went through Algebra 1, you would know that in order to cancel out the squared, we're going to need to square root both sides of the equation. And now this is a moment where you should be aware that when you're square rooting a positive number in order to get to a variable, you get both the positive version of that number and the negative version of that number, as in you get two solutions. And the thing to remember about that, about why that works, is we are looking for a number to plug into x so that we can make a true statement out of this equation where the left side equals the right side. That is, after all, what equations are meant to do. So if I were to do 4 times positive square root of 13 squared equals 52, the square and the square root would obviously cancel, so it's just 4 times 13 equals 52, which is totally legit. And now, if we try it with the negative version of radical 13, square root of 13, it turns out that the negative square root of 13 squared also gives me a positive 13. And because when you take a negative number and square it, you get the same result as getting the positive version of that number, this solution also works. And that's why it's important for you to be aware that when you're square rooting a positive value, the result is allowed to be both the positive and negative version of that number. So that's how we know D is the correct answer. However, as I will show you many times later on, when dealing with quadratic equations, a lot of times, especially if you're dealing with multiple choice, a lot of times the best way to do it is to work off the solutions that are given to you. And now let's try some practice problems. Okay, so I have two slightly different equations to solve for here, and this time there's no multiple choice because I just want to show you the technique of how to deal with situations like this, and I want to teach you something with these two questions. So with x minus 7 squared equals 64, the x minus 7 is in parentheses and it's being squared. So in order to get to the x minus 7, I must cancel out the squared by square rooting both sides of the equation, so that on the left side I have x minus 7. And on the right side, when I square root this positive number, the result gets to be both the positive and negative version of the square root of the number I'm square rooting. And now that I have x minus 7 equals positive and negative 8, it no longer makes sense to deal with this as one equation. You now have to make sure to split it up into two versions of this equation. And by simply solving each one, you can get to your two final answers for what x is relatively easily. And I know that in Algebra 1, they teach you to check your answers always by plugging it into the equation. After I do the next problem, I will show you a rule of thumb that shows you when you don't have to check your answers. So for now, for A, answer is x equals 15 and x equals -1. And now for part B, notice that this time I have the same part on the left side where x minus 7 squared, and on the right side, instead of positive 64, I have negative 64. So in terms of getting to x, the first move is exactly the same. We're going to need to be square rooting both sides of the equation. So the left side, we just get x minus 7. On the right side, I should get square root of negative 64. Now I'm going to show you guys what happens when you plug in square root of negative 64. And notice that it says an error because I have a non-real answer available. So a rule you should remember about negative numbers is that you can never take the square root of it and get a real value. So this part, so the square root of negative 64 actually does not exist. And the reason that is the case is because, remember now, we are trying to find a value for x to make this equation true. And whether you take a positive number and square it, a negative number and square it, or even taking 0 and square it, none of it, there will be 0 times where you can actually get a negative value as a result. And therefore, any equation where you've isolated to the point where you have any kind of quantity squared equaling a negative value, it is automatically going to be an equation with no solutions. And the rule of thumb going from here forward is you can figure out whether a quadratic equaling another number, you can tell whether it works or not based on whether the number on the other side of the equation is positive or negative. If it's positive, then your solutions definitely work, and if the result of your square ends up being a negative value, then it definitely does not work. And if you keep that rule of thumb in your head, that can save you a lot of trouble when dealing with quadratic equations in the future. So this is one way to solve quadratic equations, is when you have when it's simple enough for you to just solve it. However, I'm sure most of you have seen by now that most times you deal with quadratic situations, the equation they give you is not so simple. So then we talk about another way to find solutions of a quadratic equation, which is the quadratic formula. Now, for those of you that's hit Algebra 1, this formula is probably drilled into your head. Given that you have an equation that fits the form of ax squared plus bx plus c equals 0, and you have your value for a and b and c, you are always able to find the solutions or zeros. Once again, they're the same thing in terms of quadratic equations. You can find the solution by following the quadratic formula of negative b plus minus square root of b squared minus 4ac all divided by 2a. And of course, once you simplify whatever the radical is, it turns into two solutions where you're doing negative b plus whatever is inside the square root divided by 2a, and then you have the other solution of negative b minus whatever is inside the square root divided by 2a. And once you calculate both those values, these are always going to be your two solutions. And with that technique in mind, we're going to try our first problem. Okay, so I have the equation radical 13 minus x is equal to x minus 1. Now, for a problem like this, you should recognize that you're not going to solve it by dealing with something inside of a radical, so the radical needs to cancel. And just like you cancel out a square with the square root, you cancel out a square root with the square, which means we need to do both sides of the equation. So on the left side, I get 13 minus x, nice and easy. And on the right side, I get x minus 1 squared, which expands into x minus 1 times x minus 1. If you decide to FOIL it, you get x squared minus x plus 1 equals 13 minus x. And from here, if you move everything to one side of the equation, you get x squared, minus x minus 12. And from here, you can match it onto the form of ax squared plus bx plus c equals 0. And guys, one thing to remember is the quadratic formula only works when your ax squared plus bx plus c is equal to 0. Without this number being 0, this formula is completely worthless. So let's try to use a quadratic formula. And as I plug it into the quadratic formula of negative b, so it will be negative of negative 1 plus or minus square root of negative 1 squared plus or minus 4 times 1 times negative 12, all divided by 2 times 1. And as we simplify this, we get x equals 1 plus or minus square root of 1 plus 48 over 2, which now is looking a little bit clearer as 1 plus or minus square root of 49 over 2, also known as 1 plus or minus 7 over 2. And at this point, once you have the fractions simplified, I highly recommend you do 1 plus 7. You branch it off into two equations. So a plus version and a minus version. And then from here, you can simplify into your two final answers. And now we are aware that x is equal to 4, negative 3, which is b right over here. But remember that when we find our solutions for a quadratic equation, we need to make sure we're not going to be squaring or square rooting into a negative value. And if you try negative 3, and for x right now, then you're going to get square root of 16 is equal to negative 4, which is obviously not going to be the case. So then a equals 4 would be my final answer. Now, this was a adequate and technical use of the quadratic formula, and we were able to go through it in order to isolate the two perfect answers. And then narrow down the bad answer so that we get to A. But as you probably noticed, that took a long time. So we're going to look for a faster method to do this problem. And when you're dealing with quadratic equations in SATs, the proctor wants you to use a quadratic formula because it is the longest possible way to solve a quadratic equation. However, if you remember that quadratic equations are just that, equations, and you're dealing with multiple choice, then you know that they've already given you the answer. You just got to find out which one doesn't work. So simply by plugging numbers in and trying it out, you can know whether something is supposed to work or not. For example, if I plug in 9 as my solution, I would end up with square root of 4 equals negative 10, which obviously makes no sense. So then that one's bad. And guys, when you're working off of process of elimination, try the bad answers first, because that usually knocks out a lot of options for you. For example, if I try to plug in -3 as x right now, I know that I'm going to be taking a square root of a value that gives me a negative number, which is literally never going to happen. So then C doesn't work. And now not only do I know C doesn't work, I know B doesn't work because it includes -3 as an answer choice. And by process of elimination, or by plug-in, if you're paranoid and want to try it out on your own, you'll notice that that's actually a much faster way to do it. So the quadratic formula is a good way to do things, to do certain things, but it's certainly not a good way to solve for equations, especially for multiple choices, because after all, you can always just plug in your individual answer choices and check to make sure the left side equals the right side. And do make sure that you do check that, because it is a rookie mistake to use a quadratic formula, find your two numbers, and say B is the answer and call it quits. So work your answers. Okay, so now we're going to find another usage for the quadratic formula that's actually much more beneficial for us and efficient for us to use, which is the concept of how many solutions do I have? Now, at this point, we've already established that when you take the square root of a negative value, the answer is always an imaginary number, which means it leads to no solution. So the interesting thing about the quadratic formula is that it is very good at helping us determine how many solutions I have, and whether I'm going to have to deal with radical numbers as a part of my solution. So to show you what I mean, I will demonstrate. So in the traditional quadratic formula, you're taking your negative b value and you're adding and subtracting by whatever the radical of b squared minus 4ac is, which means in general, you are predicting that you have two solutions because you're taking negative b and you're adding and subtracting by the same exact number here. But with that being said, you have to make sure a value pops out of the square root in order to be added and subtracted by negative b. So if what's inside the square root is a positive value, that means it comes out as a real number that you can take negative b and add and subtract by and divide it by 2a, so that you end up with two results. One where the negative b is adding by the number divided by 2a, and one where the negative b is subtracting by the number and divided by 2a. And in this case, what we have is two solutions. An alternative situation that can happen from b squared minusing 4ac is that you end up with a 0 inside the square root. And if you end up with a 0 inside the square root, then the result of that is obviously going to be 0. And what happens now is that if you were to take the negative b and add by the 0 and divide it by 2a, and you were to take the negative b and minus 0 divided by 2a, you'll notice that both these fractions end up just equaling the same number of negative b over 2a, which means that when what's inside the radical is a 0, you are dealing with one solution. And lastly, the last kind of situation you might see is when you end up taking the square root of a negative number. And the thing to remember is when you take the square root of a negative number, you get an imaginary number, which is not a real number, which means for them to ask for real number solutions is impossible. So then when you square root of a negative number, you know that there are no possible ways. for me to do negative b plus or minus that number. So then this would be a situation where you recognize that there is no solution. And to put it in a more simplified way of representing, so you can try this on your own, if what's inside the radical, which is b squared minus 4ac, is greater than 0, then that value inside the radical ends up being positive. So then you add and subtract and you get two solutions. Now, if the b squared minus 4ac is equal to 0, you know that negative b is going to add and subtract by 0, which changes nothing. So then you're going to get one solution only. And lastly, if what's inside the square root is negative, meaning that b squared minus 4ac is less than 0, then we know for sure that no real number is getting pulled out, and we are going to have 0 solutions. And for us to use this technique, notice that we don't really even have to think about the negative b or the 2a. We simply need to figure out what number ends up inside the radical. And that gives us a good way to figure out how many solutions we are supposed to have in a particular quadratic equation, as well as detecting whether there will be radicals inside our solution. And furthermore, because we're dealing with radicals here, it also tells us whether we're going to end up with a rational number or irrational number for my final solution. And with that skill in mind, let's try two examples. So first one we have is question D right here. I have the equation y equals 2x squared minus 5x plus 27 has either 2 irrational x-intercepts only, 2 rational x-intercepts only, 2 rational, 2 irrational x-intercepts, or no x-intercepts. So first things first, we need to understand what x-intercepts mean. So x-intercept is the x value when the y value is 0. And when we solve equations, especially for quadratic equations, what we try to do is to get the equation to equal the y value of 0. And then we solve the equation this way. So that when they ask us for x-intercepts, that means I'm supposed to take this equation and make it equal 0, and then use that to help me find out what kind of solution I'm going to have. So let's get rid of the dumb answers first. You're never going to deal with a quadratic equation where you have 2 rational or 2 irrational x-intercepts. And at this point, we need to figure out whether we have 2 rational or 2 irrational x-intercepts. And this would be a good time for me to use the quadratic formula, but I'll show you how we don't need to use it to the fullest extent. So x is equal to negative b plus or minus radical of b squared minus 4ac all over 2a. Remember, before you plug in, that it's extremely important for you to list out what a, b, and c are. It is super easy to make a mistake when you don't copy the numbers down, so be sure to do that. And what we get to do now is I get to fill everything in. But I am going to show you that I am really only interested in filling in what's inside the radical here. And the reason that is the case is that if what's inside the radical ends up positive, we know that there's two solutions, or 2 x-intercepts, or 2 zeros. It's the same thing. If what's inside the radical completely simplifies, that means I have 2 rational x-intercepts because I'll be adding and subtracting by whole numbers from negative b, regardless of what negative b and a are. But if what's inside the radical isn't simplifiable, that means I have 2 irrational x-intercepts because I'm going to be taking negative b and adding and subtracting by a radical. So inside this radical, we have negative b plus or minus square root of 25 minus 4 times 2 times 27 over 2a. And right off the bat, you notice that the 25 minus 4 times 2 times 27 is going to be is going to end up being a negative value. And if you're taking negative b and adding and subtracting by the radical of a negative value, you'll know that automatically this is going to have no solution, because it is impossible to get a real number out of square rooting a negative value. And you'll notice that in this problem, I never gave any thought to b and a, and I never even actually tried to figure out what 4 times 2 times 27 is, because when you know the rule that if what's inside the radical is smaller than 0, then you have no solutions or zeros or x-intercepts, then you can automatically finish this problem by saying D must be the final answer. And compared to using the quadratic formula to solve equations, it is far, far, far more useful to use it to figure out the number of solutions you have, as well as figure out whether you have rational or irrational solutions in your final answer. And now that we did that, I want to try a mix of an algebraic approach as well as what we just did just now. So this right here we'll call question D2, since the last question was D1. So in the equation above, t is a constant. If the equation has no real solutions, what of the following could be the value of t? So if I was going to use a quadratic formula, or at least a radical part of the quadratic formula to help me do this problem, I first have to make sure everything equals 0. So I'm going to have to move that t over. In order to make everything become equal to 0. And we're going to make a equal 2, b equal negative 4. And if you're not super sure whether the t is supposed to be positive or negative, think of it this way. The minus 4x I can represent as adding by negative 4x, and the negative t I can think of as adding negative t, which is why c in this case is equal to the negative version of t. And from here on out, we're looking for the express goal of picking a number for t so that I have no real solutions, which means we're going to rely on this formula right over here, where when I do what's inside the radical, which is b squared minus 4ac, the result has to be less than 0. So then for this problem, we're going to do that representation, where we say negative 4 squared minus 4 times 2 times negative t has to be less than 0. And with this inequality, we can solve for t. I get 16 plus 8t is less than 0, minus 16 minus 16. 8t is less than negative 16. So then t must be less than negative 2. And armed with that knowledge, I just need to find the only number for t that is less than negative 2, in which case negative 3 for option A is my final answer. And this is also one of those problems where you could have simply tried your answer keys out, but just remember to make sure to turn it into the standard form anyways, because things change rapidly. When you Things change rapidly when you plug in a negative value into a negative variable. If I were to plug -3 into this situation, it would have been 2x squared minus 4x plus 3 equals 0, and we would need to solve it this way. And because we had 4 answer choices, we would have had to cycle through. I decided that it's good for us to also simply know how to set up a good inequality to represent the situation in terms of how many solutions I'm looking for. And that's a good way to use a quadratic formula. Okay, so the next skill that we're going to talk about for finding solutions of an equation is taking a quadratic equation in standard form, where the entire where one side is completely equal to 0, and turn it into a factored form so that the answer is very, very easily visible to us. And usually that's a much faster way to solve. So the traditional high school way of solving a factored form trinomial is to use the AC method. And the AC method is where you first make sure you got your A, B, and C down. And then what you do is you first take A and C and multiply by each other. So in this case, I get 6. And now you need to break this number down into a pair of factors that has to add up to your B value. So if I had tried 1 and 6, this would not work because this adds up to 7. But if I tried 2 and 3, I know this works because 2 plus 3 is equal to the B value of 5. And now the technique is to rewrite the equation, and instead of writing it as 5x this time, we're going to break that 5x down into the two pieces I broke the 6 into before. So now it's plus 2x plus 3x plus 6 equals 0. And you'll notice now this is prettier looking because we can factor by graphing. And pull the x out of the first two terms. And then pull the greatest common factor out of the second two terms, which is going to be 3. Notice that if you're ever going to make this work, what's inside the parentheses needs to be equal. And from here, we get to combine by grouping. So I get x plus 3 times x plus 2 is equal to 0. And now we know x is equal to -3 and then -2. And that's how you can use factored form of a standard equation to find your solution relatively quickly. Now, some of you might be saying like, hey Tom, that was like quick, but that wasn't like quick. It still took us a while. And that's because while the factored form is a very effective way to solve quadratics, I would say the AC method is not something you want to use on a regular basis. The skill I use and teach to work through most quadratic equations by factoring is to use a skill of guessing and checking. Most quadratics are able to split into its factored form, which means I'm going to have a set of parentheses multiplied by another set of parentheses. And we know that the first terms of each set of parentheses always multiplies into the leading term of the quadratic. So I know that I'm going to have an x value and an x value as my first term. And from here on out, I need to decide whether I'm adding or subtracting, and also by what number, in order for it to simplify into the standardized form that I would have. And what you get to do is guess and check after you make some educated guesses. So first of all, we're going to need to decide signs. Our options are either 2 positives, 2 negatives, or 1 positive and 1 negative. So the thing to remember about multiplying binomials and distributing them is that the leading terms need to multiply into the first term, so that's why we have x and x. The second terms of each binomial need to multiply into your c value, and then add up into your b value. And once you find that pair of numbers, you can put them in here. So what I notice is that because the two numbers need to add to a positive and multiply into a positive, I know that both values here should be positive. So it's x plus some number. And for those of you that are relatively solid at a multiplication and in high school, this should be easy for you to pick out a pair of numbers. If not, if it's not easy to you, I highly recommend you hit that multiplication table up to your 12s so that you're nice and comfortable doing these in your head. So I've stalled long enough. Most of you probably figured out that the numbers are 2 and 3, and that tells us that the solution for this system is x equals -3 and -2. And notice that this time the way I'm solving it is much, much, much faster than going through the whole process of the AC method. So the SATs is definitely meant to be difficult, but it's not difficult in terms of calculations. It's difficult in terms of concept and practice. So this is absolutely a viable way to tackle the SAT problems. And with that, we move. Okay, so in this question, it tells us the quadratic x squared minus x equals 2 has two solutions. Which is the larger of the two solutions? So first of all, I'm not going to be able to do anything with this because this isn't in any form that I can deal with through the factored method or the quadratic formula. So what we need to do is get everything on one side of the equation first. And now from here, we get to make some educated guesses towards how to do this. So we know we can use a quadratic formula, but that takes a long time, so that's a no-go. We can factor using the AC method, but I would say that still took a while, so no to that one. And we're going to guess the factored form, and let's see how that goes. So it equals 0, so we're good. We know that we're going to have two sets of parentheses multiplying each other to equal 0. And the leading term here is going to be x and then x. And what you should remember is that the second numbers here multiply into the c value, but they add up to the b value of -1. So for the numbers I have inside the binomials here, I know that I am going to be adding and subtracting by these two numbers because they multiply into a negative value. And in terms of the value of the digit that I plug in here and here, because I know that the b value here is negative, I know that when I add these two numbers together, I'm supposed to end up with a negative result, so the bigger number should be put over here. Well, the only two factors for 2 is 2 and 1, so I'm going to stick 2 over here and 1 over here. And with that, if you want to double check your answers, I can show you now, but if you were doing this on the test, I really wouldn't recommend it. You can distribute this, so x times x is x squared minus 2x, and then 1 times x and then minus 2, you get plus x minus 2. And what that gives us is x squared minus x minus 2. And that's how we know that our guess factoring was successful. And from here on out, we get to say x is equal to -1 as well as +2. And when the final question asks, which is the larger of the two solutions, we are obviously going to go with +2. And that is a cheaper way for you to use the factoring method to solve quadratics. And with that, we're going to learn one more thing today. So a concept that I think a lot of high school students forget is that there are two weird formulas that deal with quadratics in the form of ax squared plus bx plus c. That always works, but it answers questions that are not often asked. So as long as you have something in standard form, the sum of your zeros is always going to follow the formula of negative b over a. So if the question doesn't bother asking you for individual solutions, but they just want to know what the solutions add up to, just do negative b over a and you'll get the answer in a split second. And if they want you to multiply your solutions together, c divided by a will give you the result of that. And these two formulas, people usually forget them, but having them is a major advantage for when you deal with weird problems, such as this one right here. The quadratic equation 2x squared plus 7x plus 5 equals 0 has two solutions. What is the sum of these two solutions? Now, I can take the time to actually solve it by factoring. I know I'm going to be 2x and x. I'm going to be adding, and I have to use a pair of factors that multiply into 5. And when I distribute them, add up to a result of plus 7x. So if I try 1 here and 5 here, they'll multiply into 5, no problem. But when I distribute, the 2x will multiply by the 5, 1 will multiply by the x. So then I'm going to end up with 10x plus 1x, which is 11x, which is clearly not the situation that we want to deal with here. But I just guessed and checked that super quick. So we still have plenty of time to switch the order of the way we place those two numbers. And as you do this more often, you'll get better at it. And now when I distribute, I get 2x squared plus 5x plus 2x plus 5 equals 0, which is exactly what we're looking for. And from here, we get to say, okay, here x is equal to -1. Here, 2x plus 5 is equal to 0, and we got to solve this thing. -5 on both sides, and we get 2x equals -5, x equals -2.5. And if I want to add the -2.5 by the -1, I get -3.5, also known as -7/2. So the sum of these two solutions is -7/2, and hallelujah, we are finally there. We broke a big sweat going through this problem, given how easy it could be. And we just simply remember that the formula for the sum of zeros is negative b over a. Because if I use that approach on this problem right now, a is 2, b is 7, c is 5, and the sum of zeros is equal to negative b over a. I will get -7/2, which, oh snap, is our solution, and that method took me 10 seconds. So these two formulas don't come up often, but it definitely pays to have them memorized. And with that, we're going to try our two tough problems of the day. First, we have 2x squared plus 5x minus 25 is equal to 0 if p and q are solutions to the equation above and p is less than q. What is the value of p squared over q squared? So first things first, let's break this down into pretty pieces. Quadratic formula will work, but it's going to take us 6 years to get it done. So we're going to guess our factored form here. We're going to get 2x and x. And what's supposed to happen here is I'm going to have one positive and one negative, and they're going to multiply into 25. And when we distribute, we're going to have a middle term of plus 5x. So we need a b value of 5. So at this point, you can guess and check. What I recommend is you game plan in your head a little bit about how to create a positive value for your b value when you add everything together. So I know that the numbers I'm going to be using are 5 and 5, but if the b value ends up being positive, then I want to have the positive value create a bigger positive value when I distribute this ultimately, which is why I'm going to stick the plus sign in front of the 5 here so that it multiplies with the 2. and I'm going to stick the negative in front of this 5 because it's only going to multiply by 1x. So now, you don't really have to do this if you know how to do these in your head, but it's good to practice as long as you're not taking the test. If I were to distribute this now, I get 2x squared minus 5x plus 10x minus 25 equals 0, and clearly this is going to match this situation, which is how I know my factored form is good. When you're first starting out, you should keep doing this, because if I were to make a mistake, now would be the time that I would see it. So with this being my solutions, I'm going to get my two solutions for this equation. One of them is x equals -5. The other one, I'm going to have to set it up as 2x minus 5 equals 0, and x ends up being equal to 2.5. So because p is supposed to be less than q, the p is the 2.5. Oh wait, if p is supposed to be less than q, then obviously the negative number is the smaller number, and then the q would be the 2.5. So now at this point, let's try to answer the actual question they have for us, which is what's p squared divided by q squared? So what's going to happen now is I'm going to have -5 in parentheses squared over 2.5 squared. And you'll notice that this is a no calculator problem, so you better hope that you have 2.5 squared off the top of your head. And if you don't, I'll show you one neat trick. Remember one thing about radicals in a fraction is that if you have a term squared over another term squared, that's the same thing as taking the whole fraction and then squaring by the whole fraction. And I'm going to do the same thing here. Instead of dealing with -5 squared and 2.5 squared individually, I'm going to turn it into one fraction, which I have the ability to simplify inside. And then my final answer comes out nice and easy and clean. So for this problem, obviously you need to know how to factor it in order to get to your solutions. But the trick is to combine it with the knowledge about this rule for radicals and fractions. Not radicals and fractions, but exponents and fractions, so that you can cut some corners and get to this answer quickly as possible. And now we're going to work on our last one. Okay, what are all the solutions to the equation above? So this problem looks easy at first and then tough, and then I'll show you how to make it easy again. So if you try to just say, oh, x is supposed to equal -3 and 5, then you miss the fact that factored form, when you get your solutions from factored form, the whole thing needs to equal 0, which is not the situation we have to deal with here. So simply just doing that is not going to solve this problem. But what we also know is that this is a multiple choice. So the solution is already one of these 4 pieces. We just need to figure out which. And first things first, it's really easy to try out some these problems, some of these answer choices when you're dealing with a factored form in a quadratic, because you can just plug the numbers in and see how it goes. For example, if I want to try A, I can plug the 5 in, so I end up doing 8 times 0 equals 5, which obviously doesn't work, so then A doesn't work. For B, I can try 2, so that I get 5 times -7 equals 5. Once again, obviously, garbage answer. So B is gone now. And now between C and D, if I try to plug this in, this is going to be a little bit of a mess. So then we don't do this, because this is not going to be a good time for us. So now what we need to do is find a different way to deal with this problem. Now we can use a quadratic formula, or we can use the factored form of the quadratic, but either way I can't use it in this situation because simply put, this thing has to equal 0. So what I have to do is simplify everything and get 0 on one side of the equation to see what I need to see. So I'm going to distribute this so that I get x squared minus 5x plus 3x minus 15 is equal to 5, and then I get x squared minus 2x minus 15 equals 5 minus 5 on both sides. And we get x squared minus 2x minus 20 equals 0. And then from here, we now can decide what a, b, and c are going to be. And from here, we can either factor it, or we can take the quadratic formula. One thing you should know is that factored form doesn't always work, especially when you have radicals. There's no way I'm going to have the foresight to separate this into x minus 1 minus 2 radical 5 in parentheses. That's just not going to happen. You can only do factored form with whole numbers. So then we're stuck to quadratic formula. But rather than plugging the whole thing into the formula, I want you guys to remember that we're really just choosing between one of two answers here, and each answer has something distinct about them, and that distinction is the radicals. Okay? Rather than plugging all three numbers into the entire formula and then crunching everything out to figure out what the final answer of x is supposed to be, we are only going to focus on this part and see whether the result of this radical simplifies into a 5 or a 21. So when we plug everything in, we get the square root of -2 squared minus 4 times 1 times -20, also known as square root of 4 plus 80, which is going to be square root of 84. And when I have the square root of 84, you have to remember that 84 is really just square root of 4 times 21, which separates into square root of 4 times square root of 21, also known as 2 times radical 21. And now that we see that it's a radical of 21, it becomes really, really simple for us to figure out that D has to be my final answer without crunching the rest of this formula and trying to find both solutions. And that is a better way to shortcut through this answer. So to recap, the quadratic formula is super, super good for deciding how many solutions you're going to have and what kind of radical you're going to have, if any. And the factored form is really, really good for finding particular solutions, but only if those solutions are integers and not irrational numbers. And that is how you can exploit the different methods of the quadratic equation to deal with different kinds of situations as easily as possible. Hope you guys learned some stuff today.